Okay, we continue with the program. Our next speaker is Mathias Frey. He's head of platform architecture at Erste Bank, Austria. In the fast-evolving space of data science, the financial sector stands as a fortress of trust and security. In this keynote address, we will embark on a journey from the world of hacked prototypes to the construction of solid, data-driven features that safeguard trust and integrity within a large bank. And the title of the presentation is Digital Data-Driven Financial Advisory.
Thank you. So I hope everyone can hear me properly. Yes. I'm very grateful to be here. Hello, Serbia. Today I'm going to talk about data-driven financial advisory in the digital space. And it's a very tough nut to crack. But since this is a data science conference, let us start with some surprising data about Serbia. At least it was for me surprising. Which is the city with the largest Serbian population? I think you all know that, right? We're here. So it's Belgrade. I think this is obvious. The question is, second place goes to Novi Sad. Actually, it's the number 3. Yeah? So this opens the question, what is the second largest city with the Serbian population? And obviously, it's Chicago in the US, right? However, I am from Vienna, or you call it Peć, which is on number 6, so still 100,000 Serbs living and working in Vienna. A couple of them are my colleagues. A couple of them we visit today actually here. So we call it Wien. But I actually live and come from a place called Traunkirchen. This is my happy place. When you go to Austria, this is the nicest city in whole Austria. We have beautiful lake. The water actually runs into the Danube and then passes Belgrade in the end. And that's my family, right? And there is a town quite close to us that is world famous. And this town is not Hallstatt. It's also not Salzburg. It's a town with a very strange name, and it's called Fucking. So be aware of the pronunciation. It's called Fucking. And they have a problem. Their road sign gets stolen quite often for obvious reasons, and it gets sold on platforms like eBay or the Austrian version of eBay. So much about the intro, yeah, strange Austrian names. But again, today I will talk about digital data-driven financial advisory. I'm Mathias Frey. I work as a platform architect for Erste Group Bank AG. So I'm not working for the bank in Austria, but I come to this a bit later. So what is Erste Group? And don't worry, this is not going to be a slideshow bombardment with how large Erste Bank is. Who is a customer, by the way, of one of our banks? So that's not too many, right? There is Erste Bank Serbia here. We have a pretty big bank in the Czech Republic and are more or less leading the market in retail in Central and Eastern Europe. Our DNA roots back over 200 years as a savings bank. So in Erste, everything is about solving the financial problems of, let's say, very normal people, catering all of the financial services for them. Throughout the past years, we've been working on an online banking platform called George, and we're extremely proud about this. So usually banks are perceived rather old school, banks are perceived as not so innovative, but with this online banking solution, we really managed to outperform the market. So today we have 10 million customers from the Black Sea in Romania up to the mountains in Austria, from the north of the Czech Republic down to Croatia at the moment, right? The Serbian bank is not yet integrated, but it will come. And George was our attempt to make banking more approachable and to help our customers understand the finances better, help our customers to manage finances better, and eventually also to solve their financial needs better, right? But my talk is not about how cool we are. At least let me show it to you or prove it to you with some data. And so last year we did some number crunching. So we took App Store reviews from the Apple Play Store, from the Apple App Store, and from the Google Play Store. So reviews like this, and we collected them from our banks, but also from our competitor banks. And on the x-axis here, you have the sentiment of these reviews. So they go from rather negative on the left side to extremely positive on the right side. And on the y-axis, you see the number of reviews, where there's just a few single reviews or are thousands of customers talking about the bank. And you see here certain competitor banks in our markets. So you might know Krebka Banka, you for sure know UniCredit or Raiffeisen, and also we had been looking at the so-called challenger banks, so the Revoluts and the N26s of this world. And I must say, I can show slides to you, how cool we are, but I can also show data to you to prove that we outperform the market with our solution. Market is getting stronger, or competition is getting stronger, and therefore, last year, so this already started much more than last year. So therefore, my boss and I were sitting together, and we were thinking, okay, what might the future bring? Because we've very successfully delivered on the promise to create an online banking solution that is very much appreciated, that people actually like. But to be honest, it just digitalized existing processes. Right? So people can nowadays wire money, they can change their limits, they can apply for loans, they can make appointments with advisors. So the typical banking stuff you can think of is now beautifully visualized. And we were sitting together and we were thinking, okay, what comes next? Is this the end of the game? Have we delivered a solution that is well appreciated, and should we turn to something else? Or is there still potential in this? Right? Remember, 10 million customers, almost. It's a huge platform across Central and Eastern Europe. So we really were thinking, what can come next? And the idea we had was, let's try to digitalize financial advisory. Because no matter what George is today, for thinking about your financial problems, for talking about your financial problems, for assessing your financial situation, you still go into a branch and talk to a human person, or you talk to friends, or you do some research online. Surprisingly, no banking application has capabilities, or big capabilities, into the direction of advising customers. Fast forward, there is a reason for that, because it's a very hard problem to solve. But after this coffee here and some mock-ups we drew on a napkin, I went back home and I started to program a little prototype. So I basically programmed a prototype that would ask a customer, hey, what's your monthly income? What's your monthly cost? And people would fill this out together with what's my age, what's my profession, a couple of simple data inputs. And I did some crunching of the numbers. I'm not a data scientist myself, so the models in the background were rather simple. It was, for example, given your income and age, we expect you have this and that already saved for your pension. Given your monthly cost, we expect you have this kind of reserve to cover emergency situations, right? So think of very simple, rather rules than real data science. And eventually I would show the results on this very ugly screen. Right? So the ugly screen, conceptually it was good. Design-wise it was a bit ugly, I think. But we were thinking of, hey, a banking application works in products because banks care about accounts, they care about loans, they care about credit cards. However, we were thinking they rather think in 3 different buckets. So that's my liquidity. This is what I do to make a daily living. The second pillar would be, that's my reserve, so emergency stuff, things to cover certain situations. And the third bucket would be future wealth or prosperity. And the reason why I say bucket is really imagine water flowing from left to right. So only if the first bucket is full, you can fill up the second bucket. And the third bucket, it can never be too full, right? So this is an endless bucket. So this kind of concept was very successful internally. So we started to assemble a team together, this time with real designers. You see it on the mock-up here, and also with data scientists. Data scientists who would start to crunch the numbers, who would try to extract the simple questions I asked from the actual data we have about people in the bank. So who knows their monthly salary? Who of you knows their monthly salary? Right? It's a very easy data point. Who of you knows their monthly cost? Trust me, everyone who raised their hand does not understand the complexity of this question. Monthly cost is something we've been discussing for 2 years, and we still don't have a good answer that you can explain to people. And this is just one example of the problems we ran into. Other problems were, of course, performance related. So we stitched together the next level prototype and put it into production for selected customers. And you know what? The infrastructure just exploded. Because a data science model written in Python that fetches data for 10 seconds and then does number crunching for 5 seconds, this will never work for an online banking solution that is bombarded by thousands of customers every second. So, to have a different title for my talk today, data is just fucking hard, right? Beware the pronunciation. It's called fucking. And what then started is a very interesting journey throughout the past 2 years. So we went back to the drawing board and we started to think, okay, why is data so fucking hard? What is the reason why we're not able to calculate these obvious results? Why can't we get these insights from the data? As we always say, as a bank, we sit on a pile of data. Data is the new oil. You know all of these statements, and still we were not capable to do anything with the data. So I had the pleasure to travel around CEE and really talk with lots and lots of business teams across our group, from Romania to Austria, Česka down to Croatia. And the business teams, they consistently gave me 4 answers, basically complaints why they had problems working with data. So answer number 1 is they said, look, Matthias, it's just hugely heterogeneous. For answering any type of business problem or question, there's 15 different databases. The documentation is spread all across the enterprise, if there even is a documentation. Getting access to the systems is a nightmare. Working with the systems is a nightmare. So heterogeneity is a big thing. And whenever somebody asks me, hey, Matthias, what's your job? I basically say, hey, I'm responsible for one of the largest hard and software museums in Europe. Because this is just what a bank is. More than you're laughing, it is really like that. If you want, I invite you and show you all of the stuff from the last 200 years. Complaint number 2, compliance. So all of the data teams said, hey, we want to see real data, we want to work with data, we want to experiment with data. All of the data science literature or the whole storytelling on the web is get people together, play around, do experiments, and then iterate your models. But with GDPR and an upcoming AI directive from the European Union, with banking secrecy, all of this does not work. It just doesn't work. Number 3, that was a very surprising insight, is a lot of companies, they now say, well, data is the new oil. We need to get the oil drillers. And they usually assemble one central team. So they hire data scientists, they put them into a room and say, hey, you're the smart guys, and whenever there is a business problem, the business will come and you will then give them the smart answers. And it just doesn't work like that. Because all of the teams I met, they told me, hey, our domain is super complex, right? You have to understand the domain. You have to understand the business. We want to sit with the data scientists, embedded, right? We need to be part of the team. So this kind of ivory tower model of centralized data science teams didn't work at all. Whereas we saw huge success with a more federated approach of data scientists sitting together with business. And the last thing I also didn't understand in the first place, my very own background is software engineering. So I'm used to get requirements, to implement these, then fix my own bugs for some time, and at some point to hope that the solution is kind of stabilized, right? This is the usual life cycle of software. However, with data, we had to learn to understand that once you have a data model and you put it into production, it already degrades, right? The quality already degrades on the first day, and it gets worse and worse. So unlike with software, you need constant monitoring. You need constant maintenance. You need to constantly care about data quality. And for the business, this basically translates to cost. So I had to convince also my boss that when we now start with data-driven features, that the whole cost input into our teams will be totally different. Right? It's not like, you've seen that we have an obsession for user experience, right? So we usually have designers and front-end developers, and they put beautiful features on the screen. Once they're ready and done. So I had to, again, convince my boss that with data-driven features, there will be constant efforts going into this thing. So you all know data as a service platform as a concept, and this was also our answer to the problem. So we said, is it possible to take away the boring and repetitive stuff from the data science teams? Can we facilitate their work? Can we enable them to work more efficiently by taking care of the stuff nobody wants to take care about, right? So I started my second career, besides being the guy for the oldest hard and software museum here in Central Europe, I started being the guy for the boring stuff. And I really love to do boring stuff. I really love to take away repetitive things and see cool data science solutions flourish on top of what we're building now. So, of course, I cannot talk about every angle and aspect of our data as a service platform, but if you think about this, it's not a technology. It's not a single thing you can buy from a vendor. It's also not one team within the bank. It's more like a mantra that we try to follow. And the mantra, again, is boring stuff needs to be put into economies of scale, right? You need to improve them and professionalize them. And the actual workers, they need to work very freely and without the hassle of the boring. So I will now show you 3 layers of what we're doing. And the first layer is sourcing, the second one is analytics, and the last one, which I think is the interesting one, is to take this into action. You all know the pyramid of data, information, and knowledge. I think it's the same, right? It just has different titles here. So on the sourcing part, we introduced Kappa architecture. For those who know terms like reactive architectures or event-driven architectures, it's very close, it's not the same. But let's rewind. The application we're trying to build is an application that can give financial advice to customers. So customers log in, and we can tell them, hey, you seem to have a cost problem because it grows over time. Or we say things like, you look underinsured, or the thing you're trying to buy, have a look, you cannot really afford this. And from an engineering perspective, this is the data structure you need to have about each and every customer, each and every second, always up to date. So you need to know from 10 million customers in our case, if we're allowed to do this, right? So the first if already shows you that there is a compliance issue here, or you have to resolve one at least. So from each and every customer, you need to know their age, you need to know their products. Now comes the big data stuff. You need to know all of the transactions happening on these products, which is literally billions of records every year. And then you also need to label these transactions, because the raw data doesn't make too much sense. But once you know, okay, this was income, this is a disbursement of a loan, this was a cash transaction, this was an ATM withdrawal, this was whatsoever, then you can start to work with this data. And just to recap on why our prototype was so much failing in the first place, because the team implemented it in their usual ways, right? The team is from digital banking, so all they do is customers log in, and very quickly we show results, because usually we don't do calculations, we just show balances. So in this helicopter mode, this works for if something is already saved in a database. You can be very fast about this, but when you try to crunch numbers, it doesn't work, right? You just have an infrastructure exploding. And our first attempt to solve the problem was, okay, let's optimize the helicopter. Let's take away all of the weight from the helicopter, make it faster. And we got it from 7 seconds down to 1.5 seconds, which was an extremely interesting Python exercise, but it was totally useless, because 1.5 seconds is still too much. You cannot afford this, because it adds to latency, and this leads to very bad user experience. So a helicopter can only carry so much, so it's the wrong architecture. And then the data team said, well, let's go to the business intelligence universe, because there we have all of the data already waiting, it's properly documented. We have technologies that can do number crunching in parallel mode. We can do this much faster, it's super cool. And there is a big but to it, because imagine you build an application that tells you, hey, everything is fine, but please consider a health insurance, because you're underinsured. And then the customer does exactly what you tell him to do, or you advise them to do, because the customer goes into a certain sales flow and buys an accident insurance online. So with this architecture here, the only thing you can show to the customer is something like, hey, thank you, you did something, and however this impacts your financial health, we can only tell you next Saturday, because the ETL job has not finished yet. So this is a really bad user experience, right? First attempt to resolve this is, let's make BI faster. Doesn't happen, right? BI is built in banks for regulatory reporting. They really don't care about digital guys wanting to publish digital features for the customers. Also, you run into race conditions. You cannot just speed this up. And then we had two very cool ideas that all didn't work out. We said, okay, let's put an API on top of Hadoop. If you understand the CAP theorem, right? You cannot put an API that requires 24/7 availability on something like Hadoop, because the database doesn't guarantee availability. And also the other way around, right? I found all of these pictures on the internet, by the way. I'm very happy about it. Also, the other way around doesn't work, right? So you do something in the digital space, and then you update your BI to. It messes up the whole lineage of data. So, however we approached it, in whatever way we approached it, it just didn't work out, because there is Einstein and space and time, and on the x-axis you have time in a bank, and it starts with quarters, right? The National Bank, for example, they want reports in quarters and months. And then you go all the way to seconds and even sub-seconds if you're into securities trading. And space is single objects versus big data. And when you think about data in a bank or any large organization, you have two big bubbles that never meet each other. And when I say never meet each other, I literally mean that the people don't know each other, or at least don't want to talk with each other, because they are I see some people nodding here, yes. So you see what a bank usually does in the left bubble, and you see what we did on digital banking, right? And there's even an event horizon here, so everything beyond the red line gets super hard to do. Right? If I would be able to select, I would go into high frequency trading. I think this is technically the most interesting thing, but I would most probably move my job to London or New York. But where I want to go is actually up here. So I'm convinced that digital data-driven advice is somewhere here on top right, because it needs huge amounts of data at low latencies. And the banks, with their current technology stack, they cannot deal with this. We're not Twitter or Facebook or any of these companies. And BI will always be too slow, and digital will always not be able to scale. So we had a look into data, and we tried to analyze, okay, when do customers actually log in? Because when we want to provide an application that the customers can interact with, you need to know when are these interactions happening. And what you see is typically interaction patterns starting from 9 a.m. in the morning, finishing at 5, a bit later, not so much on the weekends. And you even see one very strange thing here. If you have a systems outage, the problem only gets bigger and bigger and bigger, right? So imagine your ops people having real issues with keeping the system alive. Once the system comes back, it's going to get bombarded by all of the user sessions that haven't happened until then. And the system again goes down. So this is a thundering herd problem. On the data side, it's evenly spread across time. So actually the data changes evenly spread throughout the day. And so we were thinking, can we implement a Kappa architecture that does not crunch the numbers when customers log in, but that crunches the numbers when the underlying data changes? And Kappa, therefore, because we established a consistent stream of data. What I mean by that is, think of the data structure I've shown to you. This all comes in via Kafka sources in real time across the whole of Europe now. Every second I'm talking, it's a few thousand transactions happening. And this goes via one pipeline through arbitrary machine learning or rules engines. Yeah? And it's then served to 3 types of data consumers. Because no matter where data is needed in a bank, it's always an event listener, Kafka to Kafka. It's an application integrating an API. So that would be any kind of fast database serving an API. Or it's analytical stuff down here, where you need to crunch numbers in batch mode. So we established this. This is one of my happy places in the bank for the last 2 years. It took me 1 year of convincing and 1 year of building, but now we have this flowing through. And we already see lots and lots of reuse across the bank. So there are credit decisions being done here. There's user interaction being done here, and there's, of course, a lot of statistics happening down there. I'm not going to talk about analytics, because this is a data science conference, and there's many, many talks about analytics. The only thing I want to show or want to share is that, again, we take care of the boring stuff, and we allow the data scientists to do the cool stuff on top. So let me get to the last layer that I find is the most interesting one, and this is putting data into action. So the question of, okay, we took the raw data, we have it in real time, we do some fancy analytics on top, and now we want to serve it to the customers. And again here, it's a story of failures, failed attempts, and learnings from there. So the first failure we did in the whole design of our application was we confused precision with accuracy. So for example, on this screen we say, hey, your monthly cost is 2,231.17 cents. That's an extremely precise number, but nobody tells you if it's accurate or not. So this was totally meaningless for our customers at this point in time. And they started to ask, hey, we want to understand what is the data going in, right? Why do you calculate this number? I always questioned why there is something like data science. I did not understand the term, but at some point I found out, okay, it's called data science because it applies the scientific methods, right? It does experiments and continuously validates the results, right? This is the scientific method. And obviously, therefore, it's called data science. So here you see my Instagram feed, and they gave me some advertisement for vegan protein sticks for weightlifting, right? It's not my thing, right? I have a very high tolerance in seeing crappy advertisements in social media. In the banking environment, people don't have this high tolerance. So this whole mindset of we try out, we do A/B testing, we show something to the customer, people don't really accept this from their bank, right? And therefore, it gets very hard to run these fast iterations. This is a very surprising one, and a very nice one, to be honest. So this is from our corporate space. So this is not retail banking, but corporate banking. And we started to show credit scores to actual customers, even if they were low. Even if they had a poor credit score, we showed them the score, and we explained to them why the score was low. And the customer feedback was good, even with the ones who had a low score, because at least they knew what was going on, and they could start to improve. And this is the last point, that actionability is probably the most important thing. So this screen here might look nice, the number might even be precise and accurate, but it's totally not actionable, right? There is nothing the customer can do with this number. And therefore, this screen is of very low interest to customers. And while we were trying to design this application, a revolution happened, right? So you might have heard of something called ChatGPT. Of course, as a bank, we're extremely bullish on that because we are probably the most inefficient industry on the planet, dealing with documents and messaging and back and forth communication all day long. And therefore, a technology promising to facilitate this, to take away the costs from this a bit, is of course very interesting to us. So we have a production pilot out there for a very selected group of customers in Česká spořitelna, so in our Czech bank. And I think it's beautiful and it works surprisingly well. However, it comes with huge new problems, like safeguarding what the LLM is talking about, like really knowing what's going on, monitoring this, making sure that, for example, the LLM is not advising the customer to buy any stocks, right? This is something we are not allowed to do. It's a tough problem, but it's coming, with or without us. And I'm very glad to be part of the team in Erste, trying to be part of the first ones who solve this tough nut. On the way, we still do a lot of errors, right? I think I openly showed them to you today. But we try to be creative, like my neighbor town, who renamed themselves from Fucking to Fucking, and therefore they solved this road sign problem, right? So try to be creative. In the meantime, we've launched quite some cool screens or cool functionalities to our customers, and I think the sky is the limit if we manage to solve these problems. Thank you.
Yeah, we have 5 minutes per questions.
Question. So you mentioned ChatGPT. So basically, we all know that there is an issue that it takes data from all over the world, and it's not going to be. Or would you have a special kind of thing that is kind of like ChatGPT, but done to safeguard the data.
So the first and most obvious thing to do is to buy the service at Microsoft, right? So Microsoft promises a confined environment, and the data does not leave this cloud environment, right? But that's only one single thing we have to solve along the way.
Well, thank you, Mathias, for the great presentation.
Thank you. Thanks.